So we made the car, added camera and differential drive plug into it, and we were able to drive the car and see what the camera of the car is seeing, right? Now it is time to make an important step towards completion of this course, and that is to add video recording feature into our car, because we require this essential feature for computer vision tasks. We cannot write algorithms before having the video, and we need to play it again and again. In this scenario, without recording scenario, we have to play the car, load the world, make the car go, and then perform the image processing task. That is not possible, and that is very tiring. So easy process is to make it save the video and process it later. Now, when we are writing a node, as we have discussed, we need to add things into our setup.py of our package, of Python package. We need to tell it if this is going to make executable of Python or not. Okay, so in this previous STC package, or the name of the package you have, we are going to create a new file, and we are going to say video recorder.py. This is going to save the file, and I'm going to paste the code that I have, and I will discuss what it is. I can write the code in front of you, but that makes no sense, right? So OpenCV is going to be utilized for recording the video. We are going to see what is recording at that very moment, and we'll take a look into the video as well. Now this video recorder.py is a script of Python. We have to make it an executable, and we are going to do that in this portion. We need to tell the package where the Python script is placed to make it an executable. What is going to be the name of the node? It is going to be recorder node. I'm just giving it as I seem it to be an appropriate name. The second thing is, what is the name of the package? It is previous STC package. Naming points should be very carefully written. Then I would rename it and save the name. In this package, dot the name of the Python file. Okay, and then what function do you need it to run? Main. This is going to make your node an executable node, and we will see how we will be executing it. Now, anything else? No, we don't need anything else. This seems to be working fine. Let's take a look into the node, the code of this node. First of all, I hope you understand basics of ROS. The messages utilized here are sensor messages, and image has been utilized. The sensor messages is from ROS, and specifically an image message is utilized. We have created a subscriber of image from the camera on this topic available, as we were looking at through RQT image view at this specific topic, and process the data function is called whenever we receive an image, and we are receiving 1280 by 720 images at 30 fps, right? If we take a look into the model, did I change it? Let me get it back to the place it was. Now things are fine. Okay, when we obtain the image from the process data, we go into the process data, we convert the image from ROS data type into OpenCV based data type, and then we perform show the frame to the screen, so it becomes easy to see what it is recording. Now whenever we get data, we process it like this. We get in a ROS format, we convert it in OpenCV and visualize it on the screen. What is the next thing? When we obtain it in the form of OpenCV, we are going to write it using the OpenCV video writer functionality, which is very awesome. So that is the main aim of converting the ROS type of image into OpenCV, so we can leverage the OpenCV functionalities. Now in video writer, you can see I provided the path of my computer, and it would be different in yours. I'm going to save in my username as output.avi, and video writer, this is going to be the compression and 30 fps, and this resolution is going to make the video saved in a specific time. Now camera was recording in VGR, so I have to convert it into the respective conversion required to make it in appropriate colors. And the main thing, whenever we run this node through execution of the executable created by the package, this function is going to be executed, which is create the object of this file, this class, which contains all this functionality, and spin it infinitely until it crashes or you forcefully shut it down. So it is created. Let's call conversion and perform things now. So previously we were just sourcing ROS, and now we are requiring to source the package that we created as well. Why? Because we need to work on it as well. So we are going to be using it again and again. So source this workspace install, or should I bring it from the home folder? It would be better if I bring the address from home folder. This is from home folder, self install setup bash. This is the whole command. I am going to copy it, and I am going to open a bash rc file, Control H to represent all these files. The place where I pasted the ROS source, I'm going to paste, why it is not pasted, my workspace path as well. So it is going to source my workspace, and I can now perform call build inside of my workspace, because so ROS is already sourced. So things are done. Let's take a look if the executable has been produced or not. ROS to run, we are running the node, and the package is Prius, and let's double press the tab to see what are the available nodes. So we have a recorder node. If we take a look on the topics available right now, ROS to topic list, and a lot of these topics are available. Basically gazebo is still running, although I've closed it, so I will kill it, so it is no more running. Now let's perform ROS to topic list, and they are still representing, although there is nothing related to ROS is running right now. Okay, that is dangerous. Okay, let's say now I have to kill GZ server first. I'll close it and I will open it again. Let's move into our workspace, and in the next terminal I'm going to say ROS to topic list. Okay, my bad. ROS to topic list. There is nothing. Parameter event and ROS out. These are the two things. We need to run the simulation, or we could just run our recorder node, which is ROS to run the name of the package and recorder node. Recorder node is going to give an error because there is no image data available, but I'm going to again see what are the available topics. So this time we have a topic, ROS to topic, get information about this topic, which is camera image raw. So we have a subscriber ready for it, but there is no publisher. Okay, now let's run the publisher. Let's stop it and run the publisher first. ROS to launch self-driving, no, the name of the package and the world file that we saved. It is not going to work like that. Gazebo, verbos, name of the world file, which was copy the path, and world file -s lib gazebo ROS factory.so. I guess this was the command I've written here. Let me paste it so there should be no mistake, and let's run it. So it is going to execute the world file and run the simulator with the world file, and now I'm going to record the video with the node that we have written, ROS to run Prius and recorder. So it is start screen on my computer as well. Why it is not showing? Let's take a look on the nodes available. Now here it is. So it took some time, and here we have the video. Let me place things in front of it, and I think we should bring things side by side. Okay, So things are appearing at 30 FPS. We can also drive the car as well. If I start to move it, ROS2 run teleop keyboard package, and we want the teleop twist keyboard to make the car move. I'll make it move in the backward direction and then forward and then right turn. Right turns are so abrupt because we can only give left and right or front at one time. Only one command can be sent. So I'm just pushing things away. This was just to check that our car is recording the video or not. The main aim was. Let's take a look. Stop this thing and stop this thing as well. It is going to be not. It is not going to be closed. So we have to stop this recorder now. So it is closed. Let's get to the place where it was saving the video, which is home Lukman output.avi, and it is in this place. This output.avi file has been generated by OpenCV. Let's run it and take a look. Let's take a look onto the output of this video. Output.avi is 13.8 KB, which means there is an error. The error that I represented here was for some reason, and that reason is whenever you are recording a video, you need to take care of the dimensions that you have mentioned. We are running this world file, right? And in this world file, we have changed the width of our camera and the height of the image of the camera. And when we are recording, we are saying this dimension of image is going to come out. This is causing problems. That is why output.avi is just 13.8 km and it contains no video. Now we have to do is to run by proper means. We have given the proper dimensions of the images. Let's rerun everything and then we'll take a look. Let me keep it side by side so we can understand things. Let's move the car. It is not going to move. I'm going to run it again. Let's place some things in front of the car to see if the car is moving or not. Let's move the car, and it is not moving for some reason. And what could be the reason? This node was running before running these type of problems exist all the time. So I'm going to rerun it and let's see if it works or not. It is not working. So there might be some problem. I have to close it again and then rerun it. But the main point was recording of the video. If I stop this recording and then I take a look into this output.avi, let's take a look. This time it is 28.7 MB. And if I run it, can I see the video? Yes, I can see the video, and it is recorded from the same camera on the car. I place certain things in front of the car, yes, and there you can see the video is recorded from the front camera, and our car is ready for self-driving, but we have to write one more script to drive the car, and then we'll